So ideally, the way that magnetic coupling can improve surgical procedure is to have all the robotic instrument entering from a single incision to be deployed inside the abdominal cavity and manipulated and controlled by magnetic fields. So this would reduce the number of incisions required for abdominal surgery down to a single incision, and also would provide a very large workspace for the surgery to be effective.
What I really liked about the project is the fact that it mixes the mechanical, the very tough mechanical part in a biomedical way, meaning that we can exploit motors and magnets to perform surgical tasks that can really benefit the outcome for surgical procedure for patients. So here is the external controller that embeds an anchoring permanent magnet that it uses to couple with another magnets inside the device, and the two are used for moving the device around and stable dock where the device is inside the human body. The other magnet is instead controlled by a motor, and its rotation allows a second magnet coupled with this one inside the device to rotate at the same frequency. And this allows to have wireless mechanical transfer of power, so that the internal magnets is then considered like an internal motor, but with a higher power specification than normal micromotors have.
So the instrument is introduced through a surgical incision and manipulated by the surgeon. So in this case we see the external unit and the actuation magnet that is spinning. We see here the external handle that has the magnets that couples with the internal instrument, and here we see the internal instrument retracting a lobe of the liver to expose the gallbladder. This is the external handle, and by moving it we are moving the internal instrument that is coupled magnetically across the abdominal wall, as we see here. So this is the internal instrument, the surgical retractor that is moving around, moved by the external handle.